So we talk about limits. Um, limits you can plug in, right? You can plug in, and if you get a number, you're done. And if you come here, you get 0 over 0, and you got 3 situation. And those 3 is all gonna be on the test, which is next Monday. So it's not tomorrow because we have Tuesday is a weird schedule. So the first one will be cancel factor. That means you have to know how to do factoring. A lot of you guys still don't know how to factoring, which is that's pretty scary on the first test. If you don't know how to factoring, if you don't know how to do radical, which is something to do with conjugate. Combined fraction is also another one. And that's all in the previous homework. Now this one, fourth one is an absolute value. So absolute value that we say we're going to talk about later. And also here, we got a number over 0, which is you got to do one side limits. If you approach, let's say approach to A like this, then you must check. Then you must check limit x approach to A on the left, as well as limit x approach to A on the right. If it's number over 0, right? If it's a number over 0. So then you must check both sides. And you plug in about 0.1 away to see what value is it. If it's positive, it's going to be positive 30. If it's negative, it's going to be negative 30. So that's pretty much all it. But we do have absolute value case that we say is overlap both. I think yesterday somebody asked a very interesting question because I post homework questions up on the trig limit. There was a one question that looks like this. We're going to talk about that question, which is limit, which is f of x is equal to x squared minus 4 over x minus 2. And the first part, I will ask you, hey, what happened when limit x approaches 2 from the left? And what if I ask you limit x approach to 2 from the right? And lastly, of course, because the first two, it will tell you what happened when limit x approach 2. Okay, so question about this part. Now, what happened is if you have limit x approaches 2 from the left side, last year I already told you that you can decide which function is it, right? You can decide which function. This function, that just say, I can choose at 2, I'm gonna have a piecewise function. And this piecewise function, we are gonna call this x plus x minus 2. And on this side, and we talk about this very useful technique when we take a derivative or integration. It's very easy to decide the slope on the right hand side, slope on the left hand side. You can even take integration, but you have to understand the absolute value graph is based on graphic approach. It's much more efficient. And I think I was just talking to Amil, I mean not Amil, but Matthew in the lunch. We talked about square root I. I mean, to look at graphic approaches completely makes sense without any hiccup. So definitely, anytime absolute value, always look at it, the graphic part. On this side of the function, we're gonna know this is the red part of the function, which is negative x minus 2. Now, since I'm approaching 2 from the left, which function I'll be using? negative parenthesis x minus 2. And that's the decision that you had to come up with. And that's the best way to evaluate this. And you can say, okay, well, that's equal to the limit x approach 2 from the left of x plus 2 and x minus 2 and x minus 2 here. And this will cancel out and left with the negative x plus 2. And I can approach the limits now. And therefore it's negative 2 plus 2, and that's equal to negative 4. Do you guys remember this from last year? I put this on the test. A lot of people screw up. Yeah. Good. Now, 2 from the right side, that you can do limits as x approach 2 from the right side. Now you can decide to use the other function, so which is x minus 2, which is left with the x plus 2, x minus 2, and the x minus 2. Limits x approach 2 from the right. This will cancel out. Oh, sorry, I canceled wrong. Should cancel this one. So x plus 2. Limit x approach to 2 is going to be 4. So obviously those two are not the same. Limit does not exist. Last one is actually the easiest one. Got it? And now let's talk about a graph of this one. The graph of this one, if I graph on the right hand side of 2, like if I graph on the right hand side of 2, then I'm going to use the x plus 2 equation, which is x plus 2 equation is going to be like this. X plus 2 is right here. And it's going to be right here, going this way, if I use the x plus 2. And then on the left side, I'm going to use negative x, negative 2. Negative x, negative 2. So it's going to go in this way. And it's going to have this. So it becomes a jump discontinuity. Do you guys see that jump discontinuity? And this is known as a non-removable discontinuity. Discontinuity. Wait, what are you asking?
The bottom point is that
because your whisper is actually louder than your words, actually. So every time you whisper, like I can hear it from like a mile away.
Well, I'm trying not to.
I'm like,
Okay, well,
okay, what question?
wait, for the second, the line at the bottom, are you starting from negative 2? Is that supposed to be 4? Like, go down.
Where?
The second line, is that approaching negative 4? Is that what it's supposed to be?
Yeah, negative 4.
Negative 4. Okay.
Last year, like Mila coming in lunch, I told him to shut up.
Okay, you know what?
And she go like, psst. I was like,
bro, Mr. Ye, leave her alone. I'm sure you're always torturing me. What are you doing? What are you doing? How are you gonna defend yourself?
Mr. Ye asked a question instead of whisper.
She's asking me first, and then you.
Because she speaks too loud, yes. She whispered too loud. Which circle is filled in? That's good. I think they are open circle because you are canceling factor there, and that's going to be an open circle. It's not going to be filled in at all. Because what happens if you plug in 2 is 0 over 0. So it is whole on both sides. Okay, so therefore, this is non-removed discontinuity. Now, for you guys need to know, non-removed discontinuity is 2 kinds. One is what? A vertical asymptote. and the other one is a jump. And jump only including, and only like this with the absolute value function. Now, do you remember what's removable discontinuity? That's also, I'm going to put it on the test. What is removable discontinuity? Yes. Yeah, but what kind of expression that's going to give you a removable discontinuity? What? Huh? No. Rational, but any particular situations. Factor cancel. Thank you. If you have cancel factor, so let's write down this. So for your information on the test, you have to worry about how do you find vertical asymptote. That means denominator equal to 0. So that is a vertical asymptote. Jump is usually absolute value function. Now there's a removable discontinuity. You also know as a hole, which is usually come from cancel factor. Cancel factor. For example, if you have a hole somewhere, then, so let's say x squared minus 4 over x minus 2, and that x plus 2 and x minus 2 and x minus 2, the hole located at where? X equal to 2, because you cancel this, the whole x minus 2 equal to 0, x equal to 2, and that's the whole, or remove discontinuity. So you get remove discontinuity by canceling factor. You get a vertical asymptote by set denominator equal to 0. But usually after you cancel factor first, because you can have one overwrite the other one. Who was going to say, Marcos? No. Okay. Is this okay? So you should know how to find a vertical asymptote. Do you guys know how to find vertical asymptote? I think it was equation, but okay. So let's go over some theorems. Okay, there are two theorems I need you to know. You probably know who they are. There is squeeze theorem. Yep, good job. So there was squeeze theorem. How does spell squeeze? I got this.
When you put the algebra test in, you spelled it algebra.
No, I didn't.
Yes, you did. I have a picture of it.
It's on
I
Fiverr.
of it. I took it out of it. Yeah, I saw it too. I started reading it wrong.
No way, Mr. Yeah, I probably was dying.
Yeah.
I didn't die.
Algebra.
Quiet now.
Okay, so remember last time we talked about this function? Do you remember this function? Do you remember this function? What does that function do? Between where? Between 1 and -1. Now, last year I also put a different question on the test. I didn't put this one on the test. I put a different one. I put this one. And this one, I also asked you, what happened when limit x approach to 0 at x sine of 1 over x? I don't think anybody remember how to do this. And last year, like everybody just trying to memorize what I write down and just write down whatever is on the test. And usually you know clue what's going on. But this year you should be a lot better because you already here last year. You already see they already have some back image. And also let's go back and think about this equation. This equation is they are oscillating. Between which value and which value? -1 and 1. Good. So this has a range between -1 and 1. Would you say? And this one we already know because it doesn't matter what output is. The oscillation is gonna look like something like 1 over the oscillation is gonna be like sine of 1 over x, right? And this oscillation is never get higher than 1 or never get below the -1. It's just oscillating. But what I propose is today's question is a bit different than last time. What I propose today is, hey, I'm gonna change the function just tiny bit. What happens if I put an x in the front? And I will say, hey, limit x approach 0 on x sine of 1 over x is equal to question mark. And when I equal the question mark, I say, okay, I start thinking. Well, what is this function as more close to? Well, we know it closer to this one, but how far away? What's the difference between the first function and the second function? Just an x, right? Pretty much it's just only an x in the front. So somehow, hey, I just need an x in the front. And I'm going to go back to this. I say, well, first of all, I know this is true. And I'm going to paste here. I know this is true. Later, I says, well, but this is true, but it's not same as the function I give it to you. So how do I make it the same? Multiply by x. But when you multiply by x, you are going to get, hey, Thomas, you back.
You've been here the whole time.
You're not here yesterday.
No.
Everything okay?
Yeah.
I have ADHD. I get distracted very easily. Like kind of like Marcos.
What?
You're the same person.
Wait, you got fired, bro.
Okay, so now I make that true. Now what's the interesting thing is, hey, I can do, since I had, this is kind of like one side limit, I can do the one from the x. So I'm gonna say limit x approach 0 of -x, right? Is equal to what? 0, right? And we also can say limit x approach to 0 on a positive x. So basically take this, and I'll approach 0. And obviously they all equal to 0. But now, what happened to the middle function? What does it has to be? According to the sum of this, the thing has to be sandwiched into those two things, right? It's also known as squeeze theorem. It's basically squeeze both sides, and then squeeze all the way into a certain value. So I hear it's going to be limit x approach to 0 of x sine of 1 over x is also equal to 0, because on the left side it's going to go to 0, on the right side it's going to 0, and so the middle part has to equal to 0. Now you say, okay, well, this doesn't do me a justice by explaining this part. You guys can probably vaguely see what is going on, but it's actually more than that, because if I were to graph this function, and I'm going to keep this function here to show you that there is a difference, and I'm going to keep the y equal to x here, right? And I'm going to keep the y equal to -x, right? And it looks like this. These two lines right here. Now I'm going to graph the third function. I'm going to graph the fourth function here. X sine of 1 over x. You're going to be like, there's nothing because we haven't let you see what happened yet. So let me unclear this. Now we're gonna see that this is bounced between two values. And they strictly follow that negative x and positive x. And they pretty much just squeeze the oscillation into a single values. Is that pretty interesting? Right? It's squeezed into a single value. And what's interesting is this. What if I change the x, the front x, to x squared? So let's change this to x squared. And then follow same thing. So I'll show you x squared here. And I'll put an x squared here as well. So in here, right? I'm just gonna watch this side. Right? It's really disciplined that it just squeezes between two negative x squared and x squared. And you can still zoom in. You still can see as I'm keep on going toward the zeros. And so I'm gonna go as much closer to 0 as possible. And I still can zoom in. I still see that it's gonna follow that things. So eventually they all gonna, both sides gonna become 0. Does that make sense? So that's 0. So that is that. So therefore this is squeeze theorem. On the test, I will give you a function that you have to figure out how to use squeeze theorem. And eventually this is equal to 0 because this is equal to 0, this is equal to 0. Charlie, does that make sense? Yeah, Tom.
So is regular squeeze theorem just sine of not equal?
Sine of what? A sine of anything is gonna give you an output of -1 and +1. Same as cosine. Right? Not a tangent doesn't work because tangent has positive infinity and negative infinity. You look at the sine graph and cosine graph, they are oscillating between -1 and 1. It doesn't matter it's 1 over x in there. 1 over x in there to still oscillate between -1 and 1, but just in a much extremely fast frequency at 0. Outside of 0 is not that bad, but at 0 it's going to be so fast I cannot see. But even that function, if you multiply x in the front, it creates that this x on the upper inequality and lower inequality. And now those inequality can go to 0, so the middle part has to equal to 0.
So when the x's aren't there,
Then there is no at risk 0, then you'll be undefined.
oh, okay.
But if it has x or x squared in the front, even as much as square root x, I actually don't know what the square root of x look like. So square root x, I never seen this before, but it should follow, pretty much it should follow the same discipline because they should still go into, they should still go into 0. Oh, it's on only one side because there's no negative side. Pretty cool. Yeah, I guess they still go into 0 because you even approach one side. Yeah. Pretty interesting, yeah.
If you say limit approaches 0, wouldn't it be does not exist if it's only from one side?
But you can approach from the other side, one side from the other side, from the positive side. Yes, it would not make sense only in the positive side.
So what if you did 1 over x?
If you 1 over x in the front, I think that's a great question. I don't think that's gonna be working because, whoops, 1 divided by x is not, it's actually going even higher. It's going to infinity because it's and it's like this. Right. But, I mean, it's a good question. Yeah. It's gonna oscillate between negative infinity and infinity, and well, it's right in front of you. It does. It does come back. It just take a very long time. I don't know. You asking me something I don't know. It's still gonna come back. The line go up there, still had to come back. So that's why you're not able to define. It's gonna be like gonna get wider and wider. When range is gonna get longer and longer as I'm going toward x equal to 0. So it's not gonna be defined because it's even worse than -1 and +1. It's oscillating between negative infinity and infinity. You're right. I don't know how you're gonna get back. That beats me. Maybe you can find out how. Okay, so visualize the graph is very interesting. So you guys gotta be able to think of this graph in your head and think about different things. Now, another theorem is I want to talk about especially for AB kids. Well, you didn't take AB, so you go straight to BC. More power to you. That the intermediate value theorem is always on an AP exam. So that one theorem has to be on. Squeeze theorem is not on AP exam as much, but I thought it's always interesting to talk about. On UCF, they actually post a lot of tests on squeeze theorem. They actually really emphasize on it. I don't know why. That's just the way it is. Those of you guys remember intermediate value theorem, just have to know the requirement. So intermediate. Intermediate value theorems, they say, hey, I'll write down, instead of write down the whole thing, I'll just write down in like segments. So there was a requirement. The requirement is this. First requirement is it must be continuous. On a closed interval. Between A to B. The second requirement, there's another requirement. FA does not equal to FB. This is actually an interesting one. If those two requirement is true, and K is the value between f of A and FB. Okay, so I think that's a third requirement. Now the result is this. Result is then there is at least one C in A comma B where f of C is equal to K. Now, most of you guys read this one the first time, you guys don't remember what is it. But the thing is A and B must be continuous. Okay. Used to be in algebra 2, they say f of C has to equal to 0. And the f of A and f of B is one's above 0, one's underneath 0. But this time it doesn't need to be at 0. It could be anywhere between f of A and f of B. So what this is saying? This saying is like if I have A here, I have a B here. And not just say f of A is here and f of B is here. And K is somewhere in the middle. And if you start out here, You end with here. Now the requirements f(a) does not equal to f(b) because it's not going to have the same height, right? And the most important requirement is it has to be continuous. Because if f(a) equal to f(b), then there's no k, right? So somehow there, you're gonna have to at least one c that pass k. So I can go avoid as much as I can, and I can come back here. At this point, there's a c that is equal to k. I can't do it any other way. I have to get through there. And sometimes you can get through more than one. So I'm gonna build a second line. I'm gonna build a red line. I can have this. I can have a k here, a c here. I have another one. And I'll have another one. So I can have multiple C, but at least one C, right? And we talk about water bottle, this label. In the morning, this water bottle is full. This is the label right here. And Matthew come in the morning, he say, hi, Mr. Ye, take a picture of it. The water bottle's right here, right? And then 7 period come back, the water's down here. It doesn't tell you when they're gonna go through this label. It just tell you it must go through this label. If it go down, it has to go through this value. It must be at least happen once. Now I can drink it and refill it and drink it and refill and drink it and refill. I can go through as many times throughout the day, right? So that is must go through the label, and that's the best way to think about how intermediate value theorem works. Yes.
So in the result part, isn't the A comma B supposed to be in parentheses or is it supposed to be bracket?
It has, according to the book, it's a bracket because you can always reach that.
C can't be A or B. Otherwise it wouldn't fulfill. It's between A and B.
This definition between, can it be on the points? I don't know. That's what the book tells me. But you become very technical later. So I mean, I should be an engineer or a lawyer, a brown lawyer. Huh?
I got a black one right here.
Okay, you want to be a black lawyer?
You just got a black one. I want to be a black one.
Matthew, I will hire you as a black lawyer any day. Okay, I do want to talk about one particular question, though. I want to talk about this question. I want to talk about this question. Last year we did this question. F of x is equal to 4 sine of x over x. And this is a minus 2x. And this is x less than 0 and this is x greater than 0. And they say, hey, can you find the value of a where this function is continuous? Entire number line. It's continuous. So find the value of a where the function is continuous the entire line. So obviously on the left hand side function is going to be 4 sine of x over x. On the right hand side of the function it's going to be a minus 2x. So you want to find the value a. So find the value of A. How much time I have? Where f of x is continuous the entire line. Do you guys remember how to approach this? Yes? See then, how do I approach it? Well, yeah, that's a cheesy way to think about it. Huh? Because they can equal each other at any part. But you really want to think about it in terms of limit. Yes, Devin.
Limit of x approaches 0 from the left, or sine over x equals limit of x approaches 0 from the right of a next to x.
Oh, that sounds like a better think about. You actually have to approach from both ends and using the limits. What happened on the left hand side?
Limit's 4.
The limit's 4, okay. And on the right hand side is gonna be a, right? A equal to 4. Pretty cool. Good job.
You wanna know something crazy?
What?
If you set them equal to each other.
I missed Zayden's sense of humor. Okay, so let's finding the value a. So I'll give you a couple questions. Tomorrow you guys gonna have I think about take a day off tomorrow.
What do you mean take a day off?
Why? Math teachers never skip.
Don't you have don't maybe have a test tomorrow?
Maybe I can Monday.
You moved the test. Oh,
How long? Yeah. Because you're gonna come do the problem with everybody else. No, you're gonna come here and do the problem. All right, so now the next one I'm thinking about is okay. Well, also graphic approach. Do you guys understand the graphic approach? So let's just say I have something. Where's my templates go? There we go. Okay, well, that line is off. For those of you guys in AB, for some weird reason, last year, end of the year, everybody told me, I don't know anything about limits. Yeah, huh? Yes.
It's kind of different from the lesson, but are you gonna change our grades from last year?
Yeah, I will. Yeah, but you already have an A. You do.
No.
I didn't give an A. Oh, I'm not changing those gray. No, I'm not changing those gray.
What do you mean?
Your final grade is A. That's all that matters.
Oh.
That's only college look. They don't look at your quarter 1, quarter 3. They don't. I promise you, they don't. You can ask Parati if you don't believe me. I do not change. I don't not change your quarter grade. No, I do change. I think Zayden's grade need to change, right? Oh, Zayden, do you give A? End of the year?
I mean, if you want to give I
Well, you got a 3 or 4. You deserve 1. That's a W grade. So Callie, Sam might give you A, right?
You gave me the last quarter. I don't know about the front seat though.
Okay. Anyway, so also graphic approach. You have to understand graphic approach. Hopefully you guys remember this. This let's just say if I have -2, I have something. Oh, that's not -2. I can't count. Shut up. All right, so I have some type of asymptote this way, and that's gonna go like this. And on this way, I'm gonna go like this, and it's gonna go here, and there's an asymptote right here. And I'm gonna have a open circle like that. Open circle this way. Open circle this way. And close circle, open circle this way. Okay. And so this part, you just had to analyze the graph. You can say, you know, how many discontinuity are they? You can say there's 1, 2, 3. You have 3 discontinuity. You have, oh, hold on. 1, 2, 3, 4. 4 discontinuity. Do you guys see 4 discontinuity? One is an asymptote, which is what? -5. And there is a jump discontinuity at -1. There is a removable discontinuity at where? 2, because that's a hole. But not a jump, right? A jump is non-removable. And a non-removable at 5. That's a jump. Okay, so what happens if I have limits x approach to -infinity of f of x? If I say this is f of x. Now, this is the only one I need like people to get right away. So Brenda, what do you think when lemon x approach to -infinity?
For this whole thing?
Yeah.
It's approaching 1.
It's approaching 1 because it's going plateau into a horizontal asymptote. Do you see that? It's equal to 1. Oops, that's 1. 2. I can say limits x approach to -5 f of x. Thomas, what's -5 when limit x approach to -5?
The infinity.
Kelly,
Does it not exist?
why?
Because
Yep, does not exist. Thomas, do you know why? Because one's going to positive infinity, one's going negative infinity. If I go into a one number -5, you should look at it both ends, right?
Oh, because it just had the approach.
Yeah, it doesn't. Yeah, just ordering an approach. So I can probably ask the third question, says limit x approach to -5 on the left side. What do you think that is, Devin? Devin, what's -5 to the left side? Infinity, yeah, good. And I can ask you question 4. I can say, hey, what happened when limit x approach to -1 f of x? Charlie?
Is it just -1?
Julia? Can you explain, Charlie, why it doesn't exist? So your b does not exist. Excellent. Charlie, does that make sense? And what she said is actually really good. If I reach one single value, you should look at both sides. So -1 from the left side, f of x. From the left side, it's going to here, which is 3. And limit x approaching -1 from the positive side. So I always try to trick you by reach one single number, so you have to look at both sides. So if I go to -1 positive is what? Charlie, if I -1 to positive is what? -1. Now here's my question. The 7th question is, what is f of -1? Tanisha, What's f of negative 1? Make up your mind.
Where there's no home.
I just want to make you doubt yourself. Yeah, it'll be 1 because that means when x equal to -1, what is the output? The output is 1, and that's it. There's no other information. You're not looking at the limits. You're not looking at anything. Now here's the thing. So let me go with 8. Let me. So what happened when limit as x approached 2? Ilya, what happened when limit x approached 2?
There's a flat too.
Dayton? So what do you say? Does not exist is actually 2. Because they go to here is 2 and go to here is 2. Because that means when x equal to -1, what is my output? I'm not looking at the limits. I'm looking at my output. The output is the black dot.
Wait, so if it was f of 2, it would be nothing like this.
F of 2, F2 does not exist, yes. So F of 2 does not exist. Oh, it's time to do it.
Yeah.
Pretty sure.